Hello everyone, and thank you for joining me today for a special Christmas edition of Cyber Llama Talks. In this episode, I wanted to pass some of my experience in detection technology engineering and why I believe, and I think it's commonly believed, but I want to specifically focus on why there is no silver bullet in detection technology. And specifically in malware detection technology, but in general in cyber threat detection technology, there is no silver bullet. And today we're going to talk about this why, and why it's so hard to reach very high malware or threat detection levels, and what are the strategies and approaches you can use in your organization or in your product to try to solve this detection problem and the silver bullet problem. Okay, let's jump in. But before we jump into discussion why it's hard to build detection technology, let's try to first get a common understanding what detection technology is trying to achieve in the higher terms. There are two main things any detection technology really focused on. It is detection rate and false positive rate. And the definition is very simple. If you take malware you detect and divide on all malware which your product observed, you're going to have detection rate. And that's usually also multiplied by 100 to get us into percentages, right? For false positive, the equation is slightly different. It's what you detected as malware, but it's benign. So it's benign files detected as malware, so it's incorrect detection divided on all benign files. And of course that would be FP, and we also would multiply it to 100. And so many times in my career, I've seen a paper or a project or someone just posting about it and saying, oh my god, I built a new technology, it's a silver bullet, it's going to detect everything. It has a detection rate of 99% or plus, right? And then you're like, okay, what's the false positive rate? And we're like, ah, yeah, it's very low, it's 1 to 2%. And you're like, are you kidding me? 1 to 2%. Imagine the situation you have under a malware system which observes, let's say, 100,000 files a day. It sits somewhere in a mail server and observes 100,000 files a day. If you have 1 or 2% of it as a false positive, 1,000 to 2,000 false positive a day, I don't think in any book that's an acceptable solution. So what usually when we operate with the false positive, of course, such a high false positive rate is not acceptable in any production solutions. And so usually when we build a system, we set acceptable false positive rate. And it really depends on the system. But ideally you want to be maybe between this to somewhere in this range, right? So that would mean every 100,000, so you have 1 to 10 false positives. That's still not ideal, but that's what usually detection technology would target. Of course, you really would like to go to 0 here, right? And here you want to go to 100, but 0 is almost always not possible. So usually acceptable FP can be in that range. And of course it depends, right? Imagine you, instead of 100,000, you have a number like this, right? And that start to add zeros here as well. So it all depends on the system you build. In malware, specifically when we're talking about file analysis, somewhere between here is great, I believe. Of course, if you're talking about, let's say, network events, you might observe, I don't know, 100 million network events a day, then even that detection rate is false positive rate is not acceptable, because you're gonna have a lot of false positives, right? Which is not acceptable. So that's just so everyone understands what the concept of detection, the technology engineering. So you build a technology which has a goal to reach 100 in detection rate and keep 0 in false positive rate. Most likely that's not possible, so you focus on acceptable false positive rates, which depend on the task and number of objects you observe, because you see here you divide by all the objects, right? Might be from numbers I posted here or even lower. It might be slightly higher if you have maybe better, like a higher tolerance for false positive or less objects observed, but in general that's the concept. So now we know what false positive and detection rates are. How do you start? How do you build new detection technology? It's, as always, everything starts with POC, proof of concept. You're excited about your idea, you like, okay, I'm totally gonna nail it. That's the technology of the future, to new silver bullet. And let's say you spend maybe 1 to 2 months, maybe 3, maybe 4, something like that, right? You're playing around and you're using limited data set. Because you cannot really spend months of collecting realistic, like you might try to be as realistic as possible, but it's still going to be a limited data set. You cannot spend too much time, it's still not a production system, you probably don't have access to all the production data and so on. So you build it, you get something, and that would be detection rate, right? And you get somewhere to, let's say, 70%. And your false positive rate is probably a little bit higher, like on the higher end, it's probably somewhere like 0.001. And you're like, yeah, we're gonna improve it later, and it's 70, it's great, you optimize it for your limited data set, it's amazing. And you spend, you know, 1 to 2 months, maybe 3 to 4, great, now it's promising. The next stage is the first version. And here it depends on, you know, how complicated your technology is. Some technologies are more complicated than others, but you build it, and on average, again, it's from my collective experience, you would spend 6 to 12 months, because to bring anything to production is 10 times harder than building POC. You need to start using real data. There are more data, it has much more corner cases, and usually what you're gonna end up with is, I don't know, much lower detection rate than you actually expected in your first version, because that was the detection rate right here. Because real data is different from limited data set you try to. And while you were building it, you discovered new type of malware, new use cases where your technology doesn't cover. Okay, it's a first version, it's not bad. You continue working on that, right? And what's gonna happen is you're gonna continue working on that. Each improvement, like a next, let's say 10% or 10 to 15%, to bring it to what, 65, 70, it's gonna take you another year. Realistically, after a year, you have a system which detects 70% of malware. But you know, you don't accept 70, right? Everyone in this industry talks about 100% detection rates. You need to build one as well. So you push more and spend another 2 years, and you really work hard. And at some point, maybe 2 years, maybe 3, depending on, you really pushed it hard. You go to 90, maybe even 95. Your technology is golden. Everyone wants it. You spend so much time on it. It's almost a silver bullet. So what's going to happen next? Well, you get noticed. You get noticed, and now malware authors working against your technology. Because here, that was all new. You were kind of working in vacuum, you did not have an impact yet. Now you released in production, you're a couple of years in, you're working. Somewhere here, you would start to have problems that your detection goes up and down, because people really started noticing it. And to get to this 1995, it's like, I mean, honestly, I think that's almost non-realistic. I think you would get stuck somewhere in 80 to 85, best case scenario, on your top. But let's say you work, you really work hard, and at some point you realize, a few years down the road, you're still at 70. You're still at 70, and to get every next level is very expensive. It's very expensive, and you estimated that now, because malware or different threats focuses on you, to cover that might take you like 5 years. Because you know you already have a bunch of bugs accumulated, you need to fix them. And so that's kind of how any detection technology evolves. You take a static analysis of malware, some signature generation, emulator, sandboxing. It doesn't really matter. In my experience, and I work on a bunch of technology like that, that's the life cycle of any detection technology. So if you visualize it differently, and here's your 100%, your silver bullet, which saves the world, you start with POC, let's say POC is somewhere here.
6 months.
And you would start, because you didn't really get a data set really well, you would start somewhere maybe 70, right? And then you start to work in production, and the results actually dip because now it's much more realistic data set, and at some point you get to version 1. You dipped here, then you work really, really hard, and at some point you're getting to, I don't know, I give you 85. And here you really kind of like start to fight, right? That's where you start to get noticed. Here, it's your version number, maybe it's the 3rd version you have. You start notice, and then you're really getting here, and you just hang here somewhere in 70% if you invest enough resources. If you don't invest resources, your technology just gets obsolete on 5 years. So that would be more or less the graph. And again, if you put the time, maybe this 6 months, that may be another year, that may be 2 to 3 years, and that might be whatever n years you're supporting your technology. And so taking all this into account, you'd be like, wait a second, are you saying that pretty much all technologies in anti-malware suck and we somewhere in best case scenario 70%? Yes and no. Really no. That's not what I'm saying. And let me explain. What would happen if you would just focus on one detection technology. And that would be so expensive to get this line up here that most likely you at some point would give up or go bankrupt. So that's why no one does it. Like real good anti-malware companies, cybersecurity companies, cybersecurity products, they never one type pony kind of thing. They never invest just into one technology. And if you want to be good, you never do that. So what do? Let me show you what you do. So you build your first technology. And that's your primary domain. Let's say you primarily a sandboxing company, or you primarily an antivirus endpoint, you primarily a gateway security solution, or maybe NDR or something else, right? You have some sort of technology where your core team came up with, that's a new one, and that was your first one and the primary one, right? And you work on that, you've got to do 70%, and now you're really pushing that envelope to get higher, right? To get somewhere in the higher numbers. And that's fine. You do it as a core business, right? As I mentioned, at some point, the costs can be so high that would be multi-years effort to bring it here. So instead of putting all your eggs in one basket and try to solve all the problems with this one silver bullet, what you do is, those are your misses of this first technology, right? And let's say it's a sandbox misses, and yeah, there are just some samples which do not really work in the sandbox very well. It might be some DLLs which need to be loaded using reflective loading, or certain parameters, or certain conditions which are really hard to know in advance and be able to run it in the sandbox. So instead of building and building and building some monstrosity which would try to load every single sample even if it's not really possible, you build a different technology. And let's say you build some static analysis and machine learning technology which analyzes the code, right? And that's your second. And you cover what your primary technology missing. You cover the gap. Some of that might be overlap, which just gives you a better confidence in this, right? In this range, you now have like even better confidence. Some of this you miss with one technology, you detect with another. And overall detection rate of the second technology may be somewhere in 60s. That really doesn't matter. You're not really trying to solve a silver bullet problem. And here you might be pushing into somewhere 85, right? That's your primary thing on your golden ages. And then when you see that's not enough and it will be too expensive to solve this gap with that two technology, you build the third one. And the third one might be even more specific. For example, it might analyzing some strings or some specific patterns. It might analyze memory modification and so on. Or it might be completely different domain, which would be even better. For example, that's a network traffic analysis, right? And that just covers that threads which others misses, right? So now you have this region which cover. And overall, that might be 50 detection rate here. And at some point, you build another one, right? And what you're trying to do is you try to really close the gap. Maybe here, and some pieces here, right? That's detected. Like if the whole thing is the all samples, this field is the detected samples, right? What you're trying to do, you try to engineer a detection technology from different perspectives. If one focused on dynamic analysis, another one focused on memory analysis, another one focused on string analysis, another one focused on something else, like whatever your team is able to come up, maybe network traffic analysis, URL analysis. And you see every next technology might actually be in absolute numbers, have a lower detection rate numbers. That doesn't matter, because what actually matters is this. If you combine all this, you might get to 95 plus. And that's your goal. Your goal is not to build a silver bullet, one technology, and detect all malware with that, or all the threats, because that's pretty much not possible. In my experience, your goal is to build an arsenal of the different technologies which try to utilize different weaknesses of the attacker, of the threat, of the malware, to make it really, really hard and really, really expensive to evade all of them. Because it's one thing to just evade sandbox, or just evade endpoint, or just evade emulator, but it's a different thing when you try to evade all of them, and all of them are black boxes, and not all of them are even accessible by the attacker, right? So, and all of them evolve all the time, right? Because you constantly try to push that envelope. You constantly try to increase those areas, right? Here on all the technologies, you're trying to improve. You try to push your primary technology to detect better. And that's your goal. And that's what good advanced malware detection technology, and I think good threat detection technology should strive to really cover the ground and make sure it's really, really hard to bypass. So next time you're building a new silver bullet or a new technology, or maybe you're thinking about starting the company, think about not just your primary attack, but what would be your secondary, third, and fourth choices, what a complementary technology you can add from the early stage of your product, so it's better when the attackers would start actively try to bypass you and more resilient to bypass. And if you are buying a technology, or let's say you're building your own SOC, or you're doing security engineering in the company, and you're buying something, and the vendor comes to you and say, hey, we have a best sandbox, we have a best machine learning. Ask them what else do they have? What are those second, third, fourth? Like when their first primary attack is going to be popular and start to be bypassed, what do they have in their sleeves? What do they invest into? Because if they don't have the answer to that, most likely it's that's dead. I don't know how to translate that, but that's what this technology is. the vendor has to have answers how they build the whole arsenal of the technology and how they're gonna be resilient to evasion when evasion comes. Because defensive evasion will always come, malware never sleeps, the threat actors never sleep. They would always come up with one way or another to bypass any silver bullet. That's why you have to have a whole revolver ready to go. I hope you enjoyed the video. Thank you very much. And yeah, don't forget to subscribe. Share with your friends if you find it helpful. I would really appreciate you spreading the word. Thank you very much. See you next time.